Good morning, good afternoon, everyone. Thank you so much for joining us today. I hope that we are complete. This is your host, Ben Manesi speaking. I'll be the one talking about Domino security today. If I could please ask for a quick confirmation that my screen is visible and that you guys can hear me, that would be awesome. Thank you so much. Great. All right. So let's actually get started. What is it that we're going to talk about today? We'll talk about everything Domino security. And as you've probably heard yourself, a lot of people say Domino is an extremely secure system, much more secure than any of the competitors, which I actually tend to agree with. We're going to examine whether this is really true and all the things that you'll need to examine in order to make it so. So we're going to talk about different things, and I'm going to take a little bit of a different approach as opposed to usual webinars that we do. There's going to be a lot of hands-on stuff in this webinar today. So we'll get started with talking about HTTP passwords and a little bit about the cryptography that's behind the scenes here, because that's extremely important and one of the potential biggest bottlenecks when it comes to Domino security. We'll then move on to protection from the inside. So what is it that you will need to examine inside your environment to make sure that there is no possibility of a rogue user or an administrator to do bad stuff. And we will then, of course, talk about web security, so protection from the outside, if you like. And then we'll move on to brute force attacks, which are going to be one of the most popular attacks about any platform ever that's visible from the outside. And then we'll talk about a lot of the remedies and everything that you'll need to know. So I'm hoping that you might see something that you haven't seen before, and that we will manage to establish a set of things that you can do to make your Domino platform bulletproof. Now, this is a white trio webinar, so we will be talking about some of our tools, but it will be much less about our stuff than the core topic of the presentation than usual. Actually, one of the things that we'll do a little bit differently here is that I will be showing a lot of attack simulations. And now I just remembered that I forgot to add a legal side, so I'm just going to say this out loud, is that anything that I do and any of the tools that I use here, please use at your own risk and responsibility, and use it responsibly and only against systems that you own or systems that you receive permission for. So the last thing that I want to do is to provide actual weapons against Domino security and Domino environments out there. Great. So like I said, we'll talk about we'll actually see a lot of attack simulations live, as well as I will mention a couple of horror stories. As probably some of you know, security is a hobby of mine, and as a certified ethical hacker, I've had the chance to do a number of security reviews for Domino and even non-Domino environments. So we've got a couple of things that I think are pretty entertaining and interesting stories. All right, so let's actually get started with the first part. Let's talk about HTTP passwords and cryptography. Why is this so important? It's because this is sort of the heart of everything that has to do with authentication from the outside as well as in the inside. So what are the basics of HTTP passwords? Just to make sure that we're on the same page here. Essentially, these can be one of the most important vulnerabilities in Domino if things are not set up correctly. And a lot of different things use HTTP passwords, a lot of different protocols that we'll see today. So it's pretty important to talk about what happens when the user authenticates. Essentially, we know that this password is stored somewhere, and so it actually is stored inside person documents, and it will be stored in the HTTP password field. However, the way that it is stored is actually not in plain text. It's in a format that we call a hashed format. So let's talk a little bit about the algorithms that come into play here. What are the hashing algorithms that are used by Domino, and what are their characteristics and what are their weaknesses? As it turns out, this stuff is actually not really well documented. So I've done a similar presentation about security at a number of conferences before. And what I've seen is that since this is not very well documented, a lot of customers weren't really aware of what this all means. So essentially, when it comes to hashing, it's important not to mistake this with encryption. What this is about is ensuring integrity. So I take a plain text password that I actually marked with PT here. I use my hashing algorithm on it, which essentially creates a ciphertext. However, the point in hashing is not that you can retrieve the original plain text from the ciphertext. It's supposed to be one way only. And so if we translate that into Domino, what essentially happens is that when you store an HTTP password inside the HTTP password field on a person document, that will be stored in a hashed format. So that will actually be a ciphertext. And when the user authenticates using the web against your Domino web server, it will essentially be ran through a verification algorithm whose mission is to ensure that the plain text that the user provided is exactly the same as the ciphertext that is stored inside that person document. So it will return a true or false depending on whether the authentication worked or not. Now, the interesting side of hashes in Domino is that there's actually 3 different versions, and that's what I referred to when I said that this is not very well documented. There is a version 1 hash, which was used prior to Domino 6, a version 2 that was introduced first in Domino 6, and then there is a version 3 that was introduced in Domino 8. Now, we'll talk about each of these, but let me just say before everything is that I've seen a lot of customers today in 2018 using version 1 hashes, and there is a lot of probable causes here. We'll talk about why this could even happen. But we'll talk about this a little bit later. So version 1, essentially, when it comes to hashing, we need to talk about hash properties. So what does the ciphertext look like and how does the algorithm work? Essentially, version 1 is a non-salted hash. So it means that whenever I take a plain text password, for example, the password, which we don't like it if users use that, right? But anyway, the least resistance thing applies here as well. Essentially, when I convert my password into a hash, into a ciphertext, the characteristics are as follows. It will be a hexadecimal output and 32 bytes in length. The biggest issue with version 1 is that no matter how many times I run the hashing algorithm over this plain text, it will always convert into the same ciphertext. Why is this a problem? Is because in order to verify that my password was correct, I'm supposed to always use the verify password, the verification algorithm. However, in this case, we could easily use a repeated conversion of the plain text password into the ciphertext and see if that result is the same, and then we'll know that the password was correct. Why is this a problem? Is because those verification algorithms have what they call a fig leaf protection, which means that it's actually pretty tough to brute force them anyway, using the native interfaces and the native Domino platform anyway. We'll see some examples of this later on. Now, version 2 is much more secure. This is a fundamentally different algorithm. It will actually use what we call a salt. So a salted hash algorithm will take the plain text and take a little bit of salt, which always changes. Every time I run the algorithm, it will change, and it will always result in a different ciphertext. So it means if I run the algorithm twice over the same plain text password, it will result in different outputs. You'll also see when you look at the backend of a person document with ScanEasy, for example, that the hash value will start with G. Now, the way that you can invoke this is that, and I see this a lot as well, is that the @password formula is actually very well known. However, there's a this was introduced in Domino 6, right? @hash password in formulas, which will result in a new and more secure ciphertext. Now, this can actually be verified using the same @verify password formula. And then there is a version 3 that was introduced in Domino 8, which essentially is only different from version 2 in that it is about double in size. So it's much more long. It is therefore much more hard to crack, but it does have the same characteristics. It will also be a salted hash. We have yet to see if Domino 10 introduces something more secure. For now, these are the 3 hash versions that we have in Domino. So what are the vulnerabilities and what does this all mean? Let's actually take a look at the situation. So I've got 2 different virtual machines here that I'm going to use throughout the presentation. I've got my demo environment that those of you who have seen our webinars before might have seen before. And I've got a Kali Linux distribution that I will use for all the bad stuff that I'm going to do to my server. So let's actually take a look at ScanEasy real quick and look at a person document here. Like I said, these password hashes are stored in the HTTP password field. Now, this one right away, we can see that it's a 32 character length. So it means that this will be a version 1 password. Now, let's take a look at this functionality real quick. I'm not sure if you guys are aware, there's a pretty amazing feature here, the test formula on this document feature. This will allow us to take fpassword, and then we'll just hash the password, and we'll see what happens. So this is going to be a version 1 output. And as you can see, no matter how many times I click evaluate, it will always be the same result. Okay. So this will not be the case if I create a version 2 password, which will be at hash password. So I'm going to do evaluate, and every time I click that, it's going to result in a different ciphertext. So that's the essential difference between version 1 and 2, as well as version 1 and 3. However, there is no direct way to generate a version 3 password using formulas, only through using the API. But we'll talk about that a little bit later. So what can we do to sort of audit our environment using ScanEasy to look at what sort of hashes we're using? Well, let's actually take a look at our person documents here. So this is a directory database. Of course, I'm going to have my person documents in here. I'm just going to quickly add these guys into a new My Selection folder. So that's going to be all people. And then, like I said, we're going to use the different characteristics of those hashing algorithms to find out what sort of passwords are these people using. So I'm going to do a diff on this real quick. And we're going to select the HTTP password field, and we're going to go for values. So with that, we retrieved the HTTP password value for all of these person documents. Now, you will right away see that there is some differences in the format as I go here. So this here, for example, is a version 3 password. So I'm going to add a new custom column here to look at the length. And so we're going to use a very simple formula here. All right, let's hit OK on that. And we will use evaluate to retrieve those values. And then we'll just very, very quickly categorize by what we received. Okay, I did. Yeah, there it is. Okay, perfect. So 34 actually means this is a version 1. So there's a large number of documents here that are version 1 hashes. 22 is actually version 2. So this is going to be the newer version. You can see how it uses a larger character set, and then we'll have the 51s, and these are the ones that were introduced in Domino 8. So it means we have a large number of hashes here that will be vulnerable to a lot of different attacks. And as we can see right away, there's a number of person documents that have the exact same hash. Now, if we remember, this is an issue because this essentially means that these users are using the same password. Now, while this is possible, even using version 2 and 3 hashes, here it's very, very apparent because the hash is going to be the exact same. So let's see why this is all an issue. Even if we don't have ScanEasy, and let's say we're just a simple user with reader access on our names and address book, what is it that we can do with it? Well, even if we're a simple user with reader access, meaning we could not create a shared view in that names and address book, we could create a view on our own, which would be stored in our desktop.ndk. And we could create a view like this, which essentially is a categorization. It's super simple. It just uses the length, and it basically outlines those passwords that are of different versions. Now, if I go through these passwords, eventually I'm going to find some person documents that will have multiple values in the same category, meaning that these guys, these 6 documents, 6 people use the exact same password, which let's be honest, actually limits the pool of passwords that they could be using. It's probably a very generic thing. So then I actually went ahead and created a tiny Lotus script code that will allow me to use a pretty short text file with the 100 most used passwords, and I would just do a password cracking attempt here. And we can see that we found the equivalent of password in French, which applies to all of these documents, because we can see that they all use the same password. So that's how easy it is for a simple user with reader access over your names and address book to crack those passwords. Now, if I was to try this using Lotus script over version 2 or version 3 hashes, the fig leaf protection, which essentially creates a delay in the amount of tries that you can do in a second, it will make it almost impossible to crack these passwords if they were to use version 2 or version 3 hashes. Not to mention that we wouldn't actually know if there's person documents using the same password if it was the newer versions. So that is one of the fundamental reasons that version 1 is extremely dangerous. All right, so let's take a look at what a hacker can do, because the point that I'm trying to make here is that if simple users have access to this stuff, it's extremely dangerous. So let's go into our Linux machine here, and let's use a tool called Hashcat. Hashcat is a pretty cool hash cracker tool. And we will probably not be surprised when we see that there is actually a nice number of Domino-related hash cracking algorithms. So there's the 8600, the 8700. 8600 is for version 1, 8700 for version 2, and then 9100 is for version 3 hashes. So I'm just going to quickly demonstrate here how quick it is to crack some passwords. We're going to go ahead and let me just go back. I have a bit of a butterfly situation here because I do a lot of coding now on this demo. So there we go. Perfect. All right. So I've got a text file where I collected all of my version 1 hashes. I've got a passwords file that actually, well, this one actually contains a 100,000 passwords. So that's actually a large amount. We saw that there's about 90 something documents using version 1, and we're checking that each with 100,000 passwords. All right, and we're going to put this out into an output file. I'm going to call it version 1 results. And let's actually double check that I'm doing everything right. No, I'm not, because I need to use my 8600. All right, 8600. And let's actually see. Oh, man. All right. Now let's try again. Okay, 8600, we're good to go. So we're checking about 90 something hash values against 100,000 documents. And we see that we recovered 13 and it barely took 1 or 2 seconds, right? So that was the version 1 stuff. Now, if I actually do a cat on this, there is all of my password hashes. So that's how easy that was. Now, if I change it just a tiny bit, because I added the version 2 hashes here as well, which is where the fig leaf protection and delay protection would actually kick in if this was in Domino, we'll actually see that this won't really make a difference when it comes to Hashcat. So Hashcat is extremely, extremely efficient when it comes to cracking later versions of Domino passwords, which is one of the reasons that I'm actually hoping for something more secure in Domino 10. Let's just put that into a different file. And this will take slightly longer. And we should be done pretty soon. Let me check the chat here. All right, yes, please. I forgot to say this. If you have any questions, please use the Q&A. You can see that we're at 72% here. So this is taking slightly longer. You can see that there is actually more protection here, but keep in mind that this is 100,000 passwords, right, against version 2 hashes. So the speed difference is already pretty easy to see. And if we go for the file here, then we'll see that we only managed to recover one. Well, that doesn't mean that we couldn't have done more. It's just that the password list didn't apply to those person documents. That's how easy it is to crack these passwords. And this is a huge issue because it's pretty hard to hide this stuff. So what does this all mean for our Domino environment? What we just saw is that as a simple user, we can easily create a categorized view or use ScanAzy for that matter to identify different password hash versions. Then we can use this view to identify users that use the same password if they use version 1. And in any case, it's pretty easy to export those hash values and pass it on to Hashcat. And even for a noob, it only takes like 15 minutes to figure out the syntax to crash these passwords, to crack these passwords. So the question arises, how do we protect our environment against this sort of stuff? And so let's actually take a look at that. First of all, I would say it's extremely important that we make sure that we upgrade those password versions. And this is where I see a lot of customers who didn't actually do this. Now, there is a little bit of a trick to know here, which is that between version 1 and version 2 and version 3, you don't actually need to do much to get these upgraded, because in order to create a version 2 password hash, the algorithm actually accepts a version 1 hash as well as the plain text itself. So the only thing we need to do is to go and edit our directory profile. And we're gonna wanna select the yes password verification compatible with Nodes Domino 801 or greater, right? So this means that any new person documents that we create or any passwords that we update will be upgraded to the latest version 3 hash. Now, however, the trick here is that this is not enough. And I think that that's one of the reasons why I see so many customers still stuck with the old versions, is that just by updating the directory profile, this does not happen automatically. You will need to select your person documents, and you'll need to go to actions and then say upgrade to a more secure internet password, and then select the latest version and hit OK. And this is when the actual upgrade happens. Now, this is supposed to be a completely seamless action to do. So your users are not supposed to notice anything because their password doesn't change. It's just the hashing algorithm that changes. So this is number one. And then the number two thing is, as we've seen, pretty much regardless of the hashing version, if people have access to this list of hashes, that is extremely dangerous, right? Because it's super easy to crack these. So what is it that we can do against that? Well, first of all, we want to make sure that we have a password policy that either makes them change their passwords or requires a super complex password at first. This is always a debate, right? Is whether this is functional, whether they're going to like it or not, or this is sustainable. I would strongly argue that it's important for HTTP passwords to be extremely complex. And then the second thing is that we want to make sure that this stuff, simple users creating views to display every other user's HTTP password hashes, this should not be possible. As it turns out, there's a great feature here that we can use for that, which is the extended ACLs. Now, the way that this works is you'll need to go to ACLs in advanced, and then you'll need to enable extended access. This will take a little bit of time, but once it's done, you'll be able to click the extended access button. And here, you're going to want to set up some rules. And the good thing is that not only can you use the standard pool of ACL access levels, but you also can define rules as to what people can see. So I have defined a rule for everybody at my organization by form and field access. So if I look at my person form, and then I would look at the HTTP password field, you can see that I set it to deny. So it means nobody can see the HTTP password field values. While if I look at the self entry here, I will allow them to see and edit their own. All right. So that's a pretty good way of hiding these hashes from rogue internal users. All right. So I think that's pretty much it for those password hashes. I'm going to just take a look at the questions here. What's the easiest way of converting all passwords to version 3? Theo is asking. I think, yeah, okay. Yeah, we did answer that. So upgrade the directory profile and then make sure to use that action and get those hashes upgraded. Perfect. I'm sorry, guys, that I'm going a little bit fast. I am sort of known to do that from time to time, but we have a lot of stuff to cover. I hope that it's easy to keep track of, and please let me know if there's any questions. Use the Q&A. The more questions, the merrier, right? All right, so let's talk about protection from the inside. One of the things that we always evangelize is that local domino security is close to zero. Now, what that means is that real domino security happens between the server and the client. When you look at a local database and open it in ScanEasy, for example, you will have the choice, you will have the chance to enable full access administration on that local database, no problem. The reason for this is that locally, there's no way really to enforce stuff, even though the client does enforce some security, but there is easy ways to get around that. So that is why security applies between the server and the client. Now, an example of that, right, is we know that full access administration gets around readers and author fields regulations or protection. What essentially happens if I have a database on server that contains documents that are not meant for me and have reader access protection on them, right? If I replicate that database locally, what essentially happens is that the notes client will evaluate what I can see and what I can access. And the only documents that I will get to my local replica are the ones that I'm supposed to see. So all the ones that I'm not supposed to see are going to stay on the server. If this was not the case, I would have a bunch of documents locally that were not meant for me. And I couldn't see them in a notes client, but I could easily get around that and gain access to those documents. So that is why we're saying that local and server security, it happens in the middle. All right, I'm going to share a bunch of interesting stuff here that we found to be interesting. For example, the enforce consistent ACLs role is that if it's not enabled, then no roles will apply locally. I remember as a new developer getting started in development in Notes, and I've been banging my head against the wall for a long time till I figured this out. So that's actually just something interesting. Now, since we talked about local security, another reason that local security isn't very powerful is that, let's say I've got a Domino server and I can access the Domino server on the operating system level. So I can log in as an administrator. Let's say I've got some databases on this Domino server that I'm not supposed to be able to access. Now, when I open the databases through the Notes client and through the Domino server, Domino security kicks in. However, since I can actually log in to the operating system, I could open those databases from the local machine, and thereby I could bypass the server and bypass security. So that is why A, we shouldn't have a client installation on the server in any case. And B, this is why I believe it's a good idea to have those applications encrypted on the server. Now, when you encrypt something on the server, that will be encrypted in the server's name, as in using the server's ID. And because whenever you access that application over the web or via your Notes client, it will always be the server that accesses it on behalf of you. You're not going to really notice anything. This is my opinion. There are other opinions that say that because things have been encrypted, the server has to do extra work to decrypt the information when it serves it to you, but there is no real way to prove an impact of this. So that's just food for thought. In any case, no installation on the server, no client installation on the server. All right, few interesting scenarios here. When we have a depositor in the ACL and read public access documents, they will be able to list designs, even ones that do not have the public access flag enabled. If a person has no access but write and read public documents, then they will be able to create those documents using the public access forms, as well as designs that are enabled for public access. So they could even access script libraries and all that sort of stuff. People with no access, and we discussed this earlier, will be able to create personal or shared views and folders, right? So just because you do not create a view to display some documents, that does not count as security, right? So use reader author field protection on that. Like I said, when somebody's not allowed to create shared views, then it will be stored in their local desktop.ndk, and it's actually a pain because it's extremely hard to manage from that point on. People with no replicator copy documents. So if you want to make sure that nobody copies stuff out of your database, this probably won't be enough. No replicator copy documents flag, the person will still be able to use the DXL export and import class. And so they could create a local database and get that stuff exported and then re-imported to another database. So this is a little bit of a false sense of security. And this is my favorite thing. And we're actually going to see a demo of this in a second. Let's say I have a person that I granted editor access to a database with write public access documents. However, I did not allow this person to delete anything on purpose, right? So editor automatically comes with write public access documents. Let's take a look at what happens here. I'm going to head over to my machine here. I'm going to switch to a user, and I hope I remember to switch back after, because that's where demo issues start to happen. Anyway, I'm logged in with a user who's going to look at this database and have editor access over the database without delete documents rights, but of course, write and replicate or copy documents rights. So what's going to happen here is I've been prevented from deleting stuff from this database. I will give it a try. It doesn't work, right? However, because I'm an editor and I have those public access flags, I could easily open ScanEasy. But I mean, it doesn't even have to be ScanEasy. It's like a 2-second search to find something to edit a field. I could open this document, and let me just make sure I know which one it is. So it's a test document. I will go ahead and create a new field because I'm allowed to do so, right? I'm going to call it public access, leave it as a text field, and just put one in there. I'm going to go ahead and save this document, which I can do because I'm an editor. I'm going to reopen the database, and I'm going to go ahead and just delete the document. Okay. So essentially what happened is I was not supposed to delete anything. I simply added the public access flag, set it to 1, which made the document available to me for me to delete, and I deleted it. So kind of the moral of the story, and this is something that comes from my boss, who always says that it's not actually real security only lasts until author access on a database, and he strongly prefers programming everything so that people only have author access over databases, and they will invoke agents on the server that will make the modifications for them. Because when it comes to editor stuff, this is one of the examples of why and what editors will be able to do, even though you might not want them to delete anything. So that's a couple of interesting scenarios about the inside. Now, because we're talking about interesting scenarios, right? Let's talk a few words about hidden database designs. This is something that ScanEasy can actually help with, but it's just an interesting story. So there is a way to hide the database design of applications, as we all know, right? But is there a way to turn that back? Is there a way to come back from that, right? A lot of people have called us over the years that they lost access to their database design because of a mistake or whatever, and they wanted to find a way to unhide the database design. So let's talk about what happens when the design is hidden. Well, first of all, when you hide a database design upon creation, formulas are encrypted. The decompiled Lotus script source code is removed, and there is a flag on the application level that will be enabled, and this is what prevents you from opening the application in the designer client. Now, the interesting part in this is that ScanEasy can help you unhide the database design, and I mean that in a non-hacky way, because all that we do here is we can remove the flag, and that will allow you to at least open the database in the designer client. However, you still probably won't see the decompiled Lotus script source code or the decrypted formulas. I'm saying probably because over the years, one of the things that we found is that developers tend to make the mistake that having created an application with a hidden design, they would keep refreshing the design as they update their template. And it turns out that this is actually not a good practice, because once the person that called us up managed to unhide the database design, a lot of these people actually found that the entire design, including decrypted Lotus script and formulas, were in fact there. Because what happens is that if you refresh the database design, the flag will remain saying that it's hidden. However, because of the refresh mechanism, all those formulas are going to come back, as well as the Lotus script source code. So that is sort of a leap of faith that a lot of people took with ScanEasy and then found that the developer made a mistake because what they were supposed to do was a replace design as opposed to refresh design. Okay, so that's about hidden designs. There's an interesting horror story. I kind of find it funny because it was a friend of ours. So it was a large bank with an administration and development department who did not like each other at all. And so one of the things that happens in this case is that administrators tend to take a lot of their time granting developers stuff that they ask for. For example, these guys sometimes would have to wait 3 days for a signature. Now, that's where the developer's revenge comes into the picture. Essentially, what happened is that one of these guys ended up having to ship a new template to production, and he ended up creating a new subroutine inside a document that would not be examined by the administrator upon signatures, and he would use the rich text items embed object method to try and look for the server's ID file and embed it into a rich text item in a hidden document. Yeah. Now, in order to do this, he actually needed to set the agent to have the full access unrestricted rights, but this the administrator did not really notice. So upon signature, this agent would run, grab the server's ID file, put it in a rich text field inside a hidden document, and the developer would open up ScanEasy, find the hidden document, download the ID file, which just so happened not to have a password on it. And it was also part of the full access administrators group. And so ever since that, they never had to ask for a signature. Yeah. So this is a pretty cool story. And it kind of brings me to my point where we have Agent Easy. And I wanted to show that real quick because it's part of what we do when we help people with security audits is, oh man, this is bad. All right, so I'm gonna have to skip the demo. I did add all of my keys to all of the tools except for Agent Easy, unfortunately. So with Agent Easy, you can simply load all of your scheduled agents on a server, and we will show you the runtime security level for every single agent. And one of the things that I tend to find at a lot of customer sites is that there is an unreasonably huge number of agents running with the highest runtime security levels. And a lot of people apparently don't really realize what an agent can do with that sort of passport, with that sort of authorization. It can make changes to the server operating system, among other things. So suffice it to say that this is not a best practice. Anyway, so that was another story. And all right, let me just pause here to breathe for a second. I don't have any other questions. All right, so let's move on to web security. So obviously, web security is one of the most important things about securing a Domino environment. And like I said, we're going to simulate a lot of stuff here to see what an attacker would do. So let's start with the fact that we're working from the outside, right? So we discussed a little bit of internal security, but we'll spend quite a bit of time on external security. Let's say we detect a Domino web server. Now, how hard is it to actually detect a Domino web server? It's actually super easy, frighteningly easy. There are two tools that I mentioned here, and I would encourage you guys to try and look up your company or your domain, census.io, as well as shodan.io. These are interfaces that grant you access to crawlers that crawl every single IP address systematically and over again and grab their HTTP banners as well as any other information they can find out about them. So simply looking for Domino will reveal 62,625 Domino servers that are exposed to the web. We'll talk about how to defend yourself against this stuff because this is extremely important. A lot of people who want to do bad things will come to these solutions to find their potential targets. So it's important that you do not appear in these engines. Please go ahead and check this after the webinar. So like I said, let's start with a simple Domino web server. I'm going to head over to my virtual machine. Obviously, I'm not going to work with an actual Domino web server. So I'm going to go ahead and do a quick discovery here to see if my web server answers. All right, let's see what happens here. So this is on the same network, but we'll only be working with this Domino server through the web. So as we can see, the Domino server is identified using the HTTP header, which is essentially the same result as what is responsible for being part of Shodan, right? So now I know this is a Domino server. At least I don't have the server version. But in any case, I'm going to go ahead and basically work here as an attacker would, right? So at this point, I know that I have a Domino server. So I'm going to go ahead and use a Perl script that I'm not going to really name here, but all right. I just want to see what are the applications that are actually open on this particular web server, right? So this is a quick and easy script that is very easy to replicate. That will look at a standard set of applications that we sort of know to be Domino applications and standard system databases, and it will check the web server to see if those applications are open. Now, while there is a lot of different scenarios of what can go wrong with web security, obviously I just sort of set up a somewhat realistic scenario, so that's what we're going to go through here. As we can see, the first thing that I see here right away is that catalog.nsf is left open. Now, because I worked with a preset list of system databases, being able to go into catalog.nsf is going to help us a lot. So I'm going to go and try catalog.nsf, right? What I'm looking for here, and I can already see all of the applications. I could probably crawl some usernames out of this right away. But what I want is I want to have some ammunition so that I can continue my crawling and feed more databases into my attack tools, right? So that I have a larger chance, a larger attack surface. So what we're going to do here is we're going to try and find a way to get these databases into my tools. So I'm going to go ahead and access the ACL by database view, which essentially just lists all of my applications here. I do have an issue here because this is not all of it, right? So there is a limitation in the view. However, it turns out that we can get around this pretty easily. So I'm going to do open view and let's increase the count to 1,000. So that looks better, right? So this is sort of the list that I want as an attacker. I'm going to go back to my console and we're going to do I'm actually just going to go ahead and copy this stuff and head over to the console. So we do a wget here and we're just going to download whatever we find in here. All right. So we're downloading the entire HTML page and we'll see how we can turn that into a set of bullets, if you like. Now I'm going to save a little bit of time because we're out of time a little bit. We saved those files here. So I could real quick, which I actually put here the cat content. So that's our HTML that contains all of our databases. So we're going to do a little bit of formatting here. And just bear with me for 1 second. All right, let's do this. All right, looks better. And then let's do another cut. And the other cut is going to be a simple space that looks much, much better. And we just need one last cut here, which will be taking out those quotes. And then we'll take field 1. Oh, not really. Okay, what happened here? Yeah. All right, sorry about that. All right, that's our list of databases. So let's actually put that into a file here that we're going to use with our DH script. Files webinar.txt. So it's actually right there. Perfect. So let's actually repeat our attack here. We're going to go for our host, and we're going to only see if we can reach these things, and we're going to use our new ammunition to see if we can get in there, and we're just going to want to see the results. So as you can see, the attack surface is much bigger. We found some custom applications here because essentially we went from using a preset list of system databases into being able to find applications that are custom applications that are not protected properly against anonymous users. We even actually found some mail files here that contain a wealth of information. So what I wanted to show here is that this stuff is actually really possible. You don't even need to have access to catalog.nsf as an anonymous user to get to where we are right now, but that was just an example. So let's take a look at what happened here. We actually saw that DOM-CFG is also left open. We could even deal with that a little bit further because there is a vulnerability in there, but we'll get to that in a second. So what actually happened here? We identified the Domino server based on its HTTP header, which was sort of yelling that it's a Domino server. We identified open system databases, which was super easy. Because catalog.nsf was left open, we managed to find much more ammunition. And this was a demo environment, but you could imagine the amount of information that we could find in a real life situation. We found more of these applications open, and from the point where you can actually access an employee's mail file, only imagination is the limit, right? DOM-CFG was open and even editable, which we didn't have time to check, but it was. So the question is, how do we protect ourselves against that? And this is going to sound pretty easy. Actually, the first thing to do, and I think one of the most crucial things to do, is to hide your Domino server identification from your HTTP response headers. This will make sure it's a simple notes INI line, HTTP disable server header equals 1. This will make sure that nobody will know when they look at your HTTP server or grab your banners, they won't know it's a Domino server. So it means you won't show up in a simple search that just searches for Domino, right? This won't probably allow you to hide if somebody is looking for a targeted for a target, like using .names.nsf or /names.nsf. That will still probably identify a Domino server, but this is a great way to start. And then the second thing, of course, is locking down your server's ACLs. And as Whiteria, we offer these tandem jumps where we go into customer environments, as well as I go on site to customers quite often. And so one of the things we always check is Domino web servers and access control list configurations. One of the things we always find is a fair amount of databases where anonymous is left open, right? And that could be reader access, and it could already be fatal, right? So let's actually take a look at how we can help with that. So like I said, we will take a look at some Whiteria stuff, and I do have my licenses installed here as well. So this is supposed to work out pretty easily. Actually, I might already have an ACLS session here. So let's just use this. So for those of you who don't know ACLS, this is a tool that allows us to look at one server at a time. It can actually look at and process multiple servers using our automation engine as well. But when we look at one server, we'll basically load every ACL entry from this server. And we will be able to look at their access rights. So we can simply categorize every single ACL entry on the server by its name, for example. And in this case, to make sure that we make our server bulletproof, we will also be able to use the access column as a second grouping here. And we can take a look at our default, for example. Default is left as manager for 41 databases. This is important for internal security as well. You want to make sure that internal users cannot have manager access over databases, right? So this is an issue. Now, how do we fix this issue? And this is sort of in common with the Whiteria tools, is that all I need to do to change these 41 databases is to select their ACLs, go to attributes, and then simply lower the access rights to no access, for example, and hit apply. Now, I always say this because it's important, is that none of what we just did is actually live, because we want to make sure that you don't make any mistakes. So you'll still be able to see in your status column that something has been changed. So in order to send those changes to the server, you hit apply changes. Otherwise, you can select them and you can cancel your modifications at any time using the right-click menu, right? So that's how we mass modify the default ACL entry. But we sort of started out talking about web security. So let's take a look at what really matters here, which is the anonymous ACL entry. So what we'll find here is that the anonymous, already we can see that there's 12 databases with manager access. Now, guaranteed, we found all of those 12 databases and all of the other ones that were set to at least reader using our previous attack simulation, because we found everything using catalog.nsf. So first of all, let's make sure that we decrease the access level on these. And let's just do a no access on all of these. But well, of course, there are scenarios where you do want to leave an application open on purpose. But in most of the cases, when we look at customer environments, we do find issues like this, that a bunch of databases are left open. Now, I can fix this in about 2 seconds. However, there is another issue, which is that when I look at the total amount of applications I loaded, which is 231, there is only 171 databases where the anonymous ACL entry exists, right? And so let's take a look at what the repercussions of that are. We have another pretty amazing feature, which is essentially an extension of the effective access calculation feature in Domino, which I always loved. It's the feature that you can use to take one user and evaluate their access rights over one database, right? And then you'll see what roles they have and all that stuff. However, it is a real limitation that the effective access calculation only works on one database. So why don't we use ACLS and select everything here, and then use the show effective access feature that simply lets us select the users we're interested in and then calculates their access rights, their effective access rights. So what I'm going to look at here is anonymous, and I'm going to take my server as well just for the fun of it, but I could select hundreds of users in here as well. Now we're going to go hit OK, and we're evaluating the access rights of 2 users against 231 databases. Barely takes a second, so this is pretty fast. And the results are going to be pretty self-explanatory. So we've got the selected names, which are the 2 users that we selected. And then, of course, we've got 231 databases for each of those. We will show you the effective access level. So if I expand is anonymous, I can see that there's 33 applications where anonymous comes with manager access. Now, this does not really sound like what we saw in the grid before, right? So when I looked at anonymous and I looked at the access level, and we found, I think, like 12 or something like that, databases where it was set to manager. Yeah, it was 12. So what is the difference here? Why is there a difference when we look at effective access? When we open these databases up here, we'll not only show you the effective access level, but we'll also explain why do they have the access that they have. And you'll see that if I select the 12 first entries, these are the 12 databases where there is an anonymous ACL entry and it is set to manager. However, the rest of these databases, the rest of these 21 databases will actually have manager access for anonymous, because anonymous does not exist everywhere. And that's a common misunderstanding, is that if there's no anonymous users can't access the database. If there's no anonymous entry, the anonymous rights will fall back onto the default, which is a little bit harder to control. So one of the key things to make sure on your Domino web servers is to take the anonymous ACL entry in the main grid in ACLS, and then use the copy selected ACL entries too, and then simply find out using the presence column which are the applications that do not have an anonymous ACL entry, and select them all, put the check mark in there with your spacebar, hit OK, and we're going to copy the anonymous ACL entry with no access to all of the 60 databases that did not have it before. So that is our quick response to this sort of web security. ACLs are extremely, extremely important. And one of the things that I did not have the time to add to the presentation, nor do we have the time to look at it now, is that all of this stuff, the effective access calculation and all that, this can be automated. So ACLS, even though it works with one server by itself, it will be available to perform this job across as many servers as you want. We have a blog post about that, I believe, and we have a bunch of automation scripts on our website, part of which has to do with ACLS as well. So we can repeat the same operation of retrieving effective access rights over multiple servers as well. So that is ACLS. Right, perfect. So let's see where we are. We're still talking about external security and web security. There are a couple other things that we can talk about here. Replica IDs are surprisingly important when it comes to web security. And before we go into why, let's actually examine what is a replica ID. As it turns out, I don't know if you guys looked at the design of your catalog.nsf before, but it turns out that a replica ID is nothing else than a hexadecimal representation of when the database was created. So essentially, it's a 16 characters with a column in the middle. And so the first part stands for the date and the date of when the database was created. And the second half stands for the time of when the database was created. It can be generated using an undocumented @text formula. And I'm going to show that because it's fun. Well, there's no need to deny I'm a nerd now, but yeah, so let's do an @text and let's do an @now, and let's use the star sign. You can see that is a replica ID. That would be the replica ID of a database that I just created. And as I keep changing it, you can see how the representation of the seconds and milliseconds actually also changes. So that is how a replica ID is built. Now, the other interesting part of a replica ID is that you can use a replica ID to open a database, right? So you don't necessarily need to know the path to those databases. It's enough if you know the replica ID, which just so happens to make it true that it's enough to only know when those databases were created, right? So why are we talking about this? I think we established that disclosing a list of database paths is an insanely bad mistake because it provides the attacker with ammunition. Now, replica IDs are important because if the attacker knows when those databases were created, then they will be able to use their replica IDs to open them, even though they might not know their exact path information. Now, what are the databases where an attacker could potentially even know where they are, right? Well, what are the databases that they know when they were created? Well, if I was to install a brand new Domino server and I would have all of my shiny new IBM NTF databases, it just so happens that their creation date would be the exact same creation date that your databases have, your template databases have, right? Because it was created by IBM at the exact same time. So that is why it's very, very suggested that you assign new replica IDs to your standard IBM templates so that the ammunition that people can have when they scan your Domino web server will change because the replica ID is not the same. Now, the other interesting part is that replica IDs can override URL redirections. So there are ways to set website rules to say if somebody is trying to access my names.nsf, I will show a hacker warning. However, there is a way to get around that. I cannot say this with 100% certainty because in some cases I managed to do this and in some it would throw me back to the redirection, but it did happen that the replica ID allowed me to get around a website rule redirection. So that's another piece of information. And of course, like I said, it is suggested that it's considered a best practice to assign new replica IDs to your IBM templates when you install a new Domino server. And it also just so happens that we have a tool that allows us to do just that, which is actually Database Easy. And Database Easy will allow us to do this for multiple databases. So I could simply look at every database on my Acme 01 server. I could use a quick database selection filter because in this case, I'm only looking at templates, right? And once those templates are loaded in the main grid, you'll have under tools the generate replica IDs feature that will allow me to assign brand new replica IDs to all of those templates. Now, you do want to be a little bit cautious here because, of course, this is going to break replication, but it's something to consider in any case. All right, perfect. So we talked about replica IDs, and now let's talk about the most critical system databases. We have seen one scenario where we made use of the catalog.nsf database. Of course, names.nsf is the most critical database. If this is left open, it's really a disaster because you could easily get your hands on, actually, if you guys are familiar with Nmap, Nmap has some preset domino-aware scripts that will allow an attacker to parse all of the HTTP password field hashes. And we have seen what that means. That will make it a piece of cake for the attacker to actually gain authorization to access your environment as a user. Catalog.nsf, we have demonstrated why this is an issue. And the DOM CFG, we'll get to that in a second, as well as the webadmin.nsf. Now, while the webadmin.nsf is only an issue if people can access it, so you need authentication and authorization even through the web, it has been discontinued by IBM, decommissioned by IBM, and they also suggest that you remove it from your servers along with webadmin.ntf as well. Okay, so names.nsf. Of course, it's going to be the #1 attack for every domino-aware attack because it used to be left open in a lot of cases, especially in the early 2000s. So that's the first thing that anybody would go for. And of course, it's the reason for that is that it's the heart of your domino environment. If it's left open, not only do you disclose your HTTP password hashes, but also your server information, operating system, your server IPs, and all of this really good stuff that a hacker would die for. So important to set this to anonymous, to set this to no access for anonymous users. All right, catalog.nsf. Well, I don't think we need to explain this a lot. Essentially, information, and this is true for any sort of information, whether that's person information, info about your databases or servers. Information is ammunition for an attacker. So catalog.nsf, from that perspective, is crucial. The Domino Web Server Configuration Database is what you use to create fancy login forms. And this can be a big issue because by default, this is set to have designer access for everybody, including anonymous users. And so that is an issue, not only because anonymous users can create login forms themselves, but because there is a not very documented thing here is the URL redirect, which you can theoretically use to actually, redirect all login traffic to a rogue Domino server in some case. I never actually tested this, but this does not look good at all. However, the protection of this is a little bit tricky because if you simply set anonymous to no access, then anonymous users won't be able to display the login form. So that is why the trick is to set anonymous to no access, but provide it with the public access flags, as well as make sure to set the form that you use as a login form to be available for public access users. And that way you get around this stuff. People won't be able to see your domcfg.nsf. Right. Okay, and then of course the Domino Web Administrator. Like I said, there was a vulnerability that was disclosed by a hacker, I think in 2013, where they managed to gain some administrative privileges and then managed to write stuff onto the server operating system using webadmin.nsf. So this should pretty much be public knowledge by now, is that you are not supposed to have these databases on any Domino web server or any Domino server for that matter at all. Right, some of the other databases that I have seen to be open before, ddm.nsf, again, not a good idea, mail.box in some cases. So make sure that you close that stuff. Of course, you don't want to disclose any email addresses and other sensitive information. There was an interesting scenario that I've had at a certain point. It was with a customer that we did help with some security reviews. And the only thing that they had open was their same times log.nsf. And why is that an issue? Is because we could simply see a list of every single user. We could parse a simple list of every user, thereby gain pretty important information such as the user login name. And in some cases, even some password hashes were stamped onto the documents. So it's important not to leave that open. This was another scenario, and this was really a horror story. It was a weird website that was based on WordPress, and it was all about searching members. But when I did search for a member, I noticed that there was a quick redirection that was a names.nsf redirection, right? Now, this was an organization where where searching for individual members was a good idea, but disclosing every single member along with their information wasn't. And of course, what do when you find this? You do an add people open view, and there you go. You had all of their addresses and other stuff as well. Just for the fun, I did look at domcfg.nsf, and actually I have seen this at multiple Domino web servers where people found this to be open and then created documents like this. So that kind of proves that the Domino industry is usually benevolent in the sense that we don't want to hurt anybody. It's more protective of our own. So, all right. Now let's talk a little bit about why employee names matter. And I think that this is going to be probably the last attack simulation that we do here. I did mention that any information that an attacker can gain about your environment really, really matters. So let's actually take a look at a practical example of what this means. I'm going to head over to both of my VMs, actually. Let me just do these guys side by side. All right. I'm gonna open up Console Easy quickly so that we can monitor what's going on. All right, so we have seen the web scenario, but of course, no real attacker would pass on doing a quick nmap, right? So let's do that. And it will actually return the open ports on this particular Domino server. I mean, we've already seen that HTTP is open, but what else do we have here? Well, we actually have POP3, right? Now, POP3 is not a good protocol to have open. I mean, neither is it needed or really relevant anymore, but we could just as well use LDAP or anything else. Essentially, POP3 is an interesting protocol because we can use that to sort of brute force the organization. And that's going to be my point here. So we're going to use something interesting called a harvester, which is just good to be aware of. We're going to go ahead and I did not set up this demo because this doesn't really work with demo data, but we're going to see how to do this. So we're going to look for any email addresses that use the domain acme.com, which I will pretend is an imaginary domain, but it won't have anything to do with my usernames anyway. And we're going to take the email addresses out of the results, because that's what we'll get is a list of email addresses. So we're going to look at what we, oh, sorry, I did make a mistake here. I'm a pretty nervous coder when it comes to doing things on the air per se. Okay, all right, that's the issue. No, it's not. Okay, what am I doing wrong here? I actually did do all of this stuff before. So domain is acme.com, B is Google, but not google.com. All right, so this is how it's going to work. Perfect. So let's wait a little bit. Essentially what this does is it does an automatic search over Google for any email addresses that will contain @acme.com, right? So this could be easily used against your company. And then we're going to see what we can do with those results, because essentially what I want is Domino familiar login names, because that's what I'm going to use for my brute force. So let's actually do a cut on this with the delimiter and take field 1. And so that will essentially just cut off the @acme.com, and it will leave me with John and all this other stuff, right? Which I presume in this environment would be real users. Now I could easily write that into a file, but I've already done that before. So I've got the usernames and I've got the most used passwords here, the 100,000 most used passwords. I'm gonna just remove this guy from here, and we're gonna use Hydra to try and brute force this POP3 server. Now watch the console on the left side, because that's sort of the point that I'm trying to make here. We're gonna go ahead and do a Hydra session with the 2 files for usernames passwords, and we're going to go against. Okay, does it look good? Yeah, it does look good. All right, perfect. So it's actually happening right now. An interesting thing that you'll notice is that you don't see anything on that server console, right? So this was an actual scenario that came up with a partner of ours. And so they only noticed a spike in the server's load, and they didn't know what was going on, right? This is actually sort of the same scenario for other protocols as well, such as LDAP, SMTP, POP, and IMAP in most cases. But POP3 for sure, unless you have some diagnostic tools, won't show anything. So let me just do something real quick and show a trick, because essentially when they noticed that there was something going on, they did a bit more diagnostics on this. And of course, you have some notes INI line that will help with this. Oh yeah, and you guys remember what I said about being logged in with the wrong account, right? So yeah, it's good that I caught that. Like I said, it's a webinar with way more demos than I'm usually comfortable doing, but let's just do this. So we've got the notes INI editor in ScanEasy. It's all that I use to set my notes INIs on the server. So we're going to do pop3 debug equals 1, and the 1 goes in here. So we're going to hit OK. We're going to quickly go and quit pop3. At least I'm not aware of a way to restart it directly. It won't accept tell pop3 restart like HTTP would. And then we'll just restart it. So essentially, the issue here at hand is that we don't see that there is an attack going on against POP3. So what we're going to see is that we'll apply a bunch of, and you know what, in the interest of time, I'm just going to do this in one go because I wanted to gradually show what happens as we go with different diagnostic tools. But I'm just going to go ahead and add this before we come back up with POP3. So I'm going to add POP3 debug IO and set it to 3 as well. So we'll see how we go from absolutely no information about what's going on here to, I hope that it's actually shut down at the same time. So we're going to quickly do okay, so let's do this. It will, I imagine, look like POP3 is open again. Perfect. So we're just going to repeat our attack here in a second. We'll remove the cache here from Hydra, and we're just gonna have a go at it. Now, you'll see that suddenly we start getting information about it. In fact, not only do we get information about it, but we'll be able to profile the attack, which is something that's extremely important. So for this attack, we did some crawling. We actually managed to get some usernames. And if those were real usernames here, then chances are that I would actually get in. There are actually 2 conclusions that I can right away take from what I can see on the server console, right? If I stop this just for a second so we can see what's going on. If I go up here, we can actually see the usernames and the passwords that were tried. Yeah. So you can see what was the username and what was the password for. Yeah, there it is. So user is IT and then Dragon and then whatnot. So essentially with the combination of POP3 debug equals 1 and POP3 debug IO equals 1, we managed to not only finally see something is going on the server, we actually managed to break it down to the actual users and passwords. Why is this important? Because a lot of these processes that do automatic pen testing, even though they're not supposed to, right? This is illegal. But a lot of automatic crawlers do this. Most of them are not going to be targeted. But in this case, what we simulated was an actual targeted attack because we did collect user information. And so if I was to see this on my server console, I would be extremely, extremely aware and worried because these were real users. So that tells me this was a targeted attack. The other thing that we can tell right away is that this attack went on for way too long because the passwords that we tried against each and every username actually went through for each of those users, which tells me that the internet password lockout database was not enabled. And that is a disaster when it comes to these protocols. So I kind of went a little bit ahead of myself. What did actually just happen? We identified a listening port on 110, but we could have just done the same thing with LDAP, SMTP, or IMAP. We crawled the web for domain-related email addresses. And mind you, we only use Google this time, but it's also possible to use LinkedIn, which is also pretty easy. And it returns the names of employees, which you can, again, use against an attack like that. And the whole thing would have gone completely unnoticed if we didn't notice the spike in performance in the server load, and if we wouldn't have enabled some of those diagnostic tools. So keep in mind these debug parameters. It was debug equals 1 and debug IO equals 3. I'm saying debug because all of this stuff works with LDAP, SMTP, and IMAP as well. And so how do we protect our environment? Like I said, internet password lockout is a must-have. I don't think there's any excuse not to have that. It's actually an interesting topic given the scenario that we just looked at now, because if I really did gather some employee logins, right, and I tried to go against that, if I had internet password lockout enabled, I would have kind of systematically locked out all of the employees whose login information I got correct, right? But still, it's much more of a better outcome than the opposite, which is that I would have found the actual password to get in using these protocols. Because as we know, if I get in using these protocols, I'll be able to get in using the web, and then I will be able to feed these credentials into another crawler, which will give me all of the information on all databases that I can access. For example, catalog.nsf, right? So internet password lockout is an absolute must. The good news is that it supports LDAP, SMTP, POP, and IMAP as well as of 901. And of course, like I said, profiling these attacks, I believe, is really important so that you know if this was something random or if it was something that was a targeted attack. And so some of the diagnostic tools here that work with all of these named protocols will be the debug IO as well as the protocol debug, which is usually enough to set to 1 and then have the IO set to 3. And that will communicate the usernames and passwords that were tried against your environment as well. So that is how it looks like. So if you look at your console log, this is what you're going to see. You see the IP addresses here as well as the users and passwords. So that is how you can profile your attacks. So sort of the moral of the story is that any information that any attacker can gain about your environment is bad, bad, bad. And so as a summary of all that we talked about internal security, we talked about hashes, which is sort of the key to your domino kingdom in a way. We talked about external security. And I think the point here is that you want to make sure your web servers are not listed in any of these databases. Make sure that you hide your Domino web server header information. Make sure that nothing is actually open to the outside. The fewer information an attacker can get about your environment, the better, including employee information and all that. Make sure to use the internet password lockout. Make sure to close your database ACLs and properly distribute anonymous ACL entries. And I'm going to come back to what I said in the beginning. I believe that Domino is extremely secure. If you look at the exploit database, you will see that the last attack on Domino or vulnerability that is in the exploit database was over 3 years ago, and it requires names.nsf to be open, right? So there's not a lot of this stuff that's out there, which is not true for any of our other competitors. For example, SQL, which Domino isn't prone to in any way, right? So I think that we have a really great platform, but there is due diligence that you need to do to make sure to bulletproof that environment, which is extremely important for the GDPR as well. And I know that most of you guys have been here for our GDPR webinar as well, which we did, I think, a couple of weeks back. This is available in case you want to watch it again, or if you want to catch up on it. It's whitechair.com/GDPR. And I know I was extremely fast, and it was a lot of stuff that we covered. I want to thank you for your attention. And of course, any questions or comments are welcome. We always love to know more about what you're interested in and what you thought about the webinar. So there's going to be a survey coming up on your screen soon. And yeah, let me just take a look at questions here, because there was a question from Theo, which is actually a great question. There used to be a website where you could enter your domain and it would scan for basic Domino security vulnerabilities. Does this still exist, or is there an alternative? I am not aware of a site like that. However, a lot of alternatives do exist. There is the one that I really enjoyed using is called Nessus. That's Nessus. It's actually a penetration testing tool. It's free to download. It's free to try. I think you can use it for about a week or 2 weeks. It's fairly easy to install and to manage. It is essentially a vulnerability scanner. So it works similarly to what an antivirus solution does, but it won't download a virus definitions database. It will download a vulnerability definitions database. And it's usually pretty accurate about Domino, but it doesn't really replace the need for proper testing if you're a financial organization or if you have a larger environment. So I think that Nessus is a great place to start. Yeah, so that was the only question. There were only 3 questions, which makes me wonder if I did a really good job or a really bad one. Oh, you guys are awesome. I just looked at the chat. It looks like I did a good job. So I really appreciate all the attendance. And if you guys have any questions or comments, feel free to reach out via email or Twitter. We always love the feedback, and have a great rest of your days.